Okay, so what is a titration? Okay, first of all, basically it's a way we're gonna figure out, basically some information about something. The best way is just to do an example. Okay, so let's say I have an acid and it's also got some unknown in it. Maybe it's water. Maybe it's been diluted. Maybe it's something else. We don't know. Okay, well, we want to find out. Basically, we want to find out, mass of the acid. Okay. Now, what we're gonna do is we're gonna react a base with the acid that's in my sample right here. Okay. Now, recall that if I like a neutralization reaction, basically there's some ratio of acid and base, of any type of acid and base that I can combine with each other. And it's going to give me a salt and water. Okay, so if I could find out somehow, okay, during the course of this experiment, if I could find out somehow how much an amount of the base that I added, then I can use that amount to figure out all the other products and reactants, can't I? Okay, so let's just pretend for a minute. Let's just say this was hydrochloric acid plus an unknown. Okay, and let's say it was 62 milliliters. Okay, and let's go up to our base, and let's say here's the key thing about the base is this is something that we can pick out. See, this is our unknown. We can choose whatever we want to do our titration with. So we're going to choose 0.8 molar sodium hydroxide. Okay, that's a base. And going back to just your stoichiometry and concentration, you'll know that this just means 0.08 moles of sodium hydroxide per 1 liter. Okay, but I'm going to write 1,000 milliliters. That's a liter, but usually for what we do, all our stuff's going to be measured in milliliters. We're not going to use a huge amounts. Okay, so you can go ahead and do that. So notice that during this reaction, whatever I add, okay, if I can somehow measure how much base, just like we said, we're measuring the amount of base that I'm going to add to my acid down here, then they'll cancel out and I'll get moles. Okay, so let's say it took 25. And I'm getting kind of sloppy here. Say it took 25 milliliters. Okay, and we'll get into why in a minute, but the units would cancel out and then I'd be just left with moles. Okay, so let's say here, first of all, before we do anything, and you might be confused still, before we do anything, let's go ahead and write a chemical reaction down. Okay, so what I'm going to do, I'm going to add sodium hydroxide to hydrochloric acid, right? And what's that going to produce? That's going to give me a salt in the water, so it'll be a sodium chloride plus water. Okay? This is a very important step. Now let's make sure we're balanced. Yes, we're balanced. Okay, so we're good to go. So basically, and we know this number, don't we? We know that I have 62 milliliters, but okay, and a thing where people might get confused is, they're like, well, yeah, but you have 62 milliliters of hydrochloric acid plus an unknown. Okay, no problem. We'll get to that in a minute, okay? All right. Okay, so there's one other thing that I'm going to need here before I do my experiment. And basically, I need some way of knowing, hey, when have I neutralized this acid? Okay, I need a way, see, like I'm going to add, a certain amount of base, and eventually it's going to equal out. There'll be a ratio of base and acid that's going to neutralize the solution. So basically, I'm going to need a way of figuring that out. Okay, so what I'm going to do, okay, is I'm going to take an indicator and I'm going to add it to my acidic solution. Okay, and this indicator solution it's a special one. It's going to change color in the presence of a base. Okay, and the reason why I want it to change color in the presence of a base is because eventually I'm going to keep adding base to this Okay, so let's just turn the knob on, and we're adding our base to this. It's getting more basic. It's getting more basic. It's getting a little, well, I mean, it's still acidic, but you know, I'm adding more base, and then all of a sudden I notice like a faint color change, don't I? Well, what happened right there? I mean, it's just a faint color change. Well, that means this sample right here has turned just a little bit basic. Okay? See, basically, you know, all the acid has reacted with the base in here, okay? And now it's just tipped just over the point of neutralization, okay? Because when it's exactly neutral, you know, we still don't know anything, right? But when at the moment that there's just a little more base than acid, we're going to notice a color change, okay? So we actually call that standardization. Okay, we can't call it neutralization because it's still a little bit basic, but we call it a standardized solution, okay? So basically, let's say, okay, let's just go back to our deal here. Let's you know, we have our, let's say we have our 0.08 or, yeah, moles of NaOH. Okay, of course we have 1,000 milliliters. Okay, and let's say it took 25 milliliters. Okay, after 25 milliliters, you know, I measured down, you know, and as soon as the color changed, you know, I observed my burette here or whatever, and I noticed that it took 25 milliliters to do this. Okay, well now I know the concentration, so now I can get moles. Okay, so let's just do let's just kind of look at what we did here. So we had 0.08 moles of sodium hydroxide per every liter, which is 1,000 milliliters. Okay, we started doing our little titration, and once we added a volume of 25 milliliters, we noticed that the solution became a little bit basic. Okay, so that tells me I'm going to stop adding base. Okay, and I'm going to use this figure right here to get moles. Okay, so that's going to be 0.02 moles of NaOH. Okay, so now let's take a look at our chemical reaction here. They combine in a 1-to-1 ratio. See, really there's all ones in front of these, just like in math, you know. So I take my 0.02 moles of sodium hydroxide. Is that on the page? Okay, and I got 1 mole of hydrochloric acid for every mole of sodium hydroxide. Okay, now when I do the math here, my units will cancel out. And this is a simple one. It was in a 1-to-1 ratio, but so then we'll end up with 0.02 moles of HCl. Okay, so now I know a little bit more about this. Now I know that in this acid, so in this 62 milliliters of acid plus unknown, I know that I had 0.02 moles of HCl, and from there, you know, I can find out a couple more items. I can just do my mass to mole conversion and find out. Okay, but I want to back up for a minute because remember originally we had an unknown in here. Let's just say our unknown was water. Okay, let's say we had an unknown amount of water in here. So now we can figure out the concentration of the hydrochloric acid. Okay, maybe it's diluted a little bit. The thing is what might confuse people is, you know, our chemical equation right here just had the acid and the base. It didn't include the unknown, and everyone's kind of like, well, why didn't we include the unknown? Well, because it doesn't actually participate in the reaction. Okay, you know, if I fill up a bunch of water in some hydrochloric acid, all it's going to do is dilute the acid. Okay, so it's the acid and the base are what's going to react here. okay? So I'm almost out of time, and don't worry, we'll do some more examples and we'll dive into this a little further, but that's just a basic idea.